Welcome to Star Chat, the podcast that explores the wonders of the universe and the latest developments in space exploration. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. As we gaze up at the night sky, we're reminded of the vastness and complexity of the universe. And yet, despite its enormity, our planet is not immune to the threats that lurk in the darkness. One such threat is Asteroid 2024 YR4, a small but potentially hazardous object that's been making headlines in recent months. Discovered at the end of last year, Asteroid 2024 YR4 was initially thought to have a 1 in 32 chance of hitting Earth in 2032. However, further observations reduce the probability of an Earth impact to effectively zero. But here's the thing. There's still a 4% chance that this asteroid could slam into the moon, and that's a risk that shouldn't be taken lightly. You see, if Asteroid 2024 YR4 were to hit the moon, it could put thousands of critical satellites around our planet at risk from lunar shrapnel. And let me tell you, that's a scenario that no one wants to contemplate. The good news is that astronomers have a brief window of opportunity to gather more information about this asteroid's trajectory using the James Webb Space Telescope. In February 2026, the JWST will have a narrow viewing window to observe Asteroid 2024 YR4, and this could be our last chance to decide on a deflection mission. The stakes are high, folks, and the clock is ticking. If the risk of an impact increases to more than 30%, as some predictions suggest, then space agencies will have to act quickly to prevent a potentially catastrophic event. But here's the question. Are we prepared to take action? Do we have the infrastructure and the expertise to deflect an asteroid like 2024 YR4? And what about the moon? Do we consider it a priority to protect our nearest celestial neighbor from potential impacts? These are just some of the questions that we'll be exploring in more detail on future episodes of Star Chat. But for now, let's just say that Asteroid 2024 YR4 is a reminder of the importance of space exploration and the need for continued investment in our planetary defense systems. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're diving into the fascinating world of exoplanets, and today we have a story that's out of this world, literally. Astronomers have made a groundbreaking discovery by creating the first ever 3D temperature map of a distant exoplanet. The exoplanet in question is called WASP 8D DB, a scorching, ultra-hot Jupiter located about 400 light-years away from us. This incredible achievement was made possible using the James Webb Space Telescope, which allowed scientists to map the thermal structure of the planet's atmosphere in unprecedented detail. What they found was remarkable, a hot spot, where the star's light directly hits the planet, surrounded by a colder ring. But here's the interesting part. The hot spot has less water vapor than the rest of the planet, which suggests that the heat is breaking down the water molecules. This discovery is not only exciting for scientists, but also has significant implications for our understanding of exoplanet atmospheres and the potential for life beyond Earth. The researchers behind this study are eager to apply this 3D mapping technique to other hot Jupiters, and who knows, maybe one day we'll be able to map the temperatures of smaller rocky exoplanets that could potentially harbor life. The level of detail that scientists can now achieve is staggering, and it's opening up new avenues for research and exploration. As we continue to push the boundaries of what's possible, we may uncover even more surprising discoveries that challenge our current understanding of the universe. Welcome back to Star Chat. As we conclude our journey through the cosmos today, I'd like to take you to a place where the vastness of space meets the ingenuity of human technology, the Deep Space Network. This incredible system, managed by NASA, is the backbone of our ability to communicate with spacecraft that are millions, even billions of miles away from Earth. Imagine a network so powerful and so precise that it can send commands to a spacecraft orbiting the moon or even farther out into the solar system and receive data back in real time. This isn't just science fiction. This is the reality of the Deep Space Network, which has been operating since 1963. With its three main antenna complexes located in California, Spain, and Australia, it ensures that at least one site can always maintain contact with spacecraft as Earth rotates. However, like any aging infrastructure, the Deep Space Network faces challenges. The recent damage to the Mars antenna, a critical component of this system located at the Goldstone complex in California, highlights these concerns. This antenna isn't just any part of the network. It's the largest dish and has been pivotal in tracking spacecraft traveling tens of billions of miles from Earth, including the Voyager missions that have now exited our solar system. But what makes this story even more compelling is the role the Mars antenna plays beyond just deep space communication. It serves as the world's most sensitive planetary radar, capable of pinging near-Earth asteroids to determine their position, speed, and trajectory. This capability isn't just about advancing our knowledge of space, it's also crucial for planetary defense, helping scientists identify asteroids that could potentially pose a threat to Earth. The outage of the Mars antenna due to damage has significant implications. Scheduled asteroid observations had been canceled through the end of this year, which underscores the fragility and importance of maintaining our space infrastructure. It's not just about the technology itself, but about the people and the discoveries that rely on these systems. As we look up at the stars, remembering the vast mysteries waiting to be unraveled, we're also reminded of the importance of investing in our ability to explore and understand space. The Deep Space Network is more than a collection of antennas. It's a gateway to the cosmos, enabling us to push beyond the boundaries of what we thought was possible. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.